Good morning students. Welcome to second video. In the up to first video we complete our first lesson. Now we are going to discuss some important problems in first lesson. Okay, so take your note and listen carefully and write the question and solve the answer neatly. Now coming to example 1.1, listen the question carefully. From a point on the ground, the top of the tree is seen to have an angle of elevation 60 degree. The distance between the tree and the point is 50 meter. That means the distance of the observer and the tree is 50 meter. So what about the height of the tree? Now see the question. They given angle of elevation, the theta value is 60 degree and distance 50 meters. So we have to find the height of the tree. We already know how to find the height of the tree from the triangulation method. Using the same formula, we are going to find the height of the tree. Now solve the problem. Students, first you write the given data. So the given is angle of elevation theta equal to 60 degree and distance d or x equal to 50 meter and height of the tree h equal to, we have to find. Solution, we have to find the height of the tree, no? So to find the height of the tree, we know h equal to x tan theta. From the triangulation method, we derive this formula. So substitute the known values. Therefore h equal to 50 into tan 60 degree. Since we know tan 60 degree equal to 1.732, approximately the tan 60 value is 1.732 and substitute the value there. Then we get 50 into 1.732. So multiple the value, we get h equal to 86.6 meter. That is the height of the tree is 86.6 meter. Now coming to second problem, example 1.2. The moon suspend an angle of 1 degree 55 minutes at the baseline equal to the diameter of the earth. What is the distance of the moon from the earth? Also they have given the radius of the earth is 6.4 into 10 power 6 meter. Students, we have to find the distance between moon and the earth. Now what are the data they given? Using the parallel axis method, they given the angle in degree. Okay, 1 degree 55 minutes. Actually we have to convert that value into second. Okay, also they represent the radius value. Actually we are followed the diameter for calculating the distance, that is called the basis. So let me see how we are finding the distance. Students, write the given data. So radius of the earth equal to 6.4 into 10 power 6 meter. Angle theta equal to 1 degree 55 minutes and we have to find the distance x. First of all, we are going to convert the angle into radian and also convert the degree into second. See the solution. So since we know theta equal to 1 degree 55 minutes, so 1 degree equal to 60 minutes. Okay, so we have to add the value. We get 60 minutes plus 55 minutes, nearly 115 minutes. Now this 115 minutes is converted into second. So multiple with the second, we have one constant value, that is since 1 second equal to 4.85 into 10 power minus 6 radian. That value should be multiple with 115 minutes into 60 second into 4.85 into 10 power minus 6 radian, and finally we get theta equal to 3.34 into 10 power minus 2 radian. So very carefully students, we have to convert the degree into second, then the second is converted into radian. Next we find the distance. To find the distance, we know the formula theta equal to b by x. Since we need x, so we rearranging the formula. Therefore x equal to b by theta. Now b is called basis. Actually they given the radius, so twice the radius is called diameter. So I am going to multiply with the 2. Therefore 2 into 6.4 into 10 power 6 divided by 3.4 into 10 power minus 2. Now the denominator power 10 power minus 2 move to the numerator and becomes plus, and multiple the 2 into 6.4, we get 12.8 into 10 power 6 into 10 power 2 divided by 3.34. Then divide the 12.8 divided by 3.34, we get 3.8323 and decimals going, and simply I round off with the two decimals, so we get 3.83 into adding the powers of the 10, and I get 10 power 8 meter. Therefore the distance between the earth and the moon is x equal to 3.83 into 10 power 8 meter. Next, third problem, example 1.3. A radar signal is beamed towards a planet and its echo is received 7 minutes later. If the distance between the planet and the earth is 6.3 into 10 power 10 meter, calculate the speed of the signal. Students, see the question. A signal is sent from the earth. Okay, the distance between the earth and the planet is 6.3 into 10 power 10 meter, and the echo received after 7 minutes. So what about the speed? Okay, we know the formula to calculate the speed. Now we solve the problem. Now write the given data. The distance between the earth and the planet, d equal to 6.3 into 10 power 10 meter. Okay, then time t equal to 7 minutes. Students, we have to convert the minute into second, because in SI unit we are using only second for calculating the time. So 1 minute equal to 60 second. Therefore 7 minute equal to 7 into 60, nearly 420 seconds. Then we have to find the velocity v. Solution: to find the velocity, we know the formula v equal to 2d divided by t. Okay, then substitute the value. We get 2 into 6.3 into 10 power 10 divided by 420. Now multiple the numerator, we get 12.6 into 10 power 10 divided by 420. So nearly dividing the value, I get 0.03 into 10 power 10 meter per second. Now I'm going to move to decimal, so I get 3 into 10 power 8 meter per second. Therefore the velocity is 3 into 10 power 8 meter per second. Student, next problem, example 1.4. So this problem is very important. Listen carefully. In a series of successive measurements in an experiment, the reading of the periodic of oscillation of a simple pendulum were found to be 2.63 second, 2.56 second, 2.42 second, 2.71 second, and 2.80 second. So calculate the mean value of the period of oscillation. Second one, absolute error in each measurement. Third one, mean absolute error. Fourth one, the relative error. Fifth one, the percentage error. Also we have to find the time period. So we have to find in the proper form. Students, in this question an experiment is done by students. Okay, so to calculate the time period of an oscillation, they taken 5 time set of readings. So we have to calculate the what about the errors in the reading. Let me discuss. Listen carefully. Write the given data. So consider t1 equal to 2.63 second, t2 equal to 2.56 second, t3 equal to 2.42 second, t4 equal to 2.71 second, and t5 equal to 2.80 second. So we have to calculate mean value, absolute error, mean absolute error, relative error, percentage error, and time period. Let me discuss one by one and note it carefully. First one, to calculate the mean value, we know the formula. So sum of the all the reading divided by number of reading. Okay, so therefore Tm equal to T1 plus T2 plus T3 plus T4 plus T5 divided by 5, and we get 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 divided by 5. So sum of the all reading we get 13.12 divided by 5. Nearly we get 2.624 second, and only we consider the two decimal we get 2.62 second. The mean value is Tm equal to 2.62 second. Student, second we are going to find the absolute error. We know the formula for finding absolute error, del t equal to, that is mean value minus of individual value. Okay, so one by one we find the absolute error. Del t1 equal to 2.62 minus 2.63, nearly we get minus 0.01 second. Del t2 equal to 2.62 minus 2.56, we get plus 0.06 second. Del t3 equal to 2.62 minus 2.42, we get plus 0.20 second. Del t4 equal to 2.62 minus 2.71, we get minus 0.09 second. Del t5 equal to 2.62 minus 2.80, we get minus 0.18 second. Students, we find the individual absolute error in the measurement of calculation the time. Okay. Third one, mean absolute error. Del Tm equal to sigma modulus of del Ti divided by n, which means we find the absolute errors. So for that we are using the modulus value and becomes the negative value into positive. So we get 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 divided by number of reading 5. So adding all the numerator value, we get 0.54 divided by 5, which is equal to 0.108. Rounding off, we get 0.11 second. Fourth one, the relative error. The relative error, we know the formula, mean absolute error divided by mean value. So therefore we get 0.11 divided by 2.62, we get 0.0419, and only considering the two decimal we get 0.04, the relative error value. Fifth one, we are going to find the percentage error. We know the formula for finding the percentage error. The relative error into 100% is known as percentage error. So therefore t equal to 0.04 into 100% equal to 4%. And last one, to calculate the time period, so we just add the mean value and the percentage error value. So we get t is equal to 2.62 plus or minus 4%. Student, this problem is very important, so go through carefully. Students, coming to today's assignment, complete the remaining problems given in the book. Okay, also write the what are the advantages of dimensional analysis and what are the limitations of dimensional analysis. Okay, and copy in the classwork note. Do it properly. Thank you.